The complete oil heating system begins at the tank and ends at the chimney. At the heart of the system is a tiny yet important piece of hardware, the nozzle. It performs the vital functions that keep the flame generating warm, comfortable heat. In fact, it plays such a significant role in the entire system that we at HVACRsupplyNOW.com feel that you should know a little more about how a nozzle works. So what does a nozzle do? The nozzle performs three vital functions. First, it atomizes, which speeds up the vaporization process by breaking up the oil into tiny droplets. Second, it meters. This is designed and dimensioned that it will deliver a fixed amount of atomized fuel to the combustion chamber. Lastly, it patterns. A nozzle is also expected to deliver the atomized fuel to the combustion chamber in a uniformed spray pattern and angle best suited for the specific burner. I'd like to talk a little about the three most popular types of nozzle that are in use. Hollow cone or Type A nozzles can be used in burners with a hollow air pattern and typically are used in small burners with a firing rate of 1 gallon and under. The solid cone or Type B nozzle produces a spray which distributes droplets fairly uniformly throughout the complete pattern. Typically, these nozzles may be used in larger burners such as those firing above 2 or 3 gallons per hour, providing a smoother ignition. The Type W nozzle produces a spray which is neither truly hollow nor solid. These nozzles frequently can be used in place of either solid or hollow cone nozzles between 0.4 gallons per hour up to 8 gallons per hour, regardless of the burner's air pattern. The lower flow rates tend to be hollower, while higher flow rates tend to be more solid. Spray angles are available from 30 degrees through 90 degrees in most nozzle sizes to meet the requirements of a wide variety of burner air patterns and combustion chambers. Usually, it's desirable to fit the spray angle to the air pattern of the burner. In today's flame retention burner, it's possible to fire more than one spray angle with good results. Generally, round or square combustion chambers should be fired with 70 to 90 degree nozzles. However, long, narrow chambers usually require 30 to 60 degree spray angles. To determine the proper firing rate for a house, there have been two procedures developed in determining the optimum nozzle size. One is the standard heat loss calculation method, and the other is the K-factor sizing formula. If the amount of heat loss is known, then the amount of replacement heat needed is also known. From this information, the proper size of a boiler or furnace can be determined, thus the correct nozzle size. This method can be used for determining the proper nozzle size in new construction, a new heating system in an existing house, or a new oil burner installation. This method requires extensive measurements of the house and other construction details. The K-factor sizing formula is a sizing calculation that meets oil dealer and heating contractor needs for a quick procedure to determine the proper nozzle size for existing heating systems. The K-factor calculation uses oil dealer records of degree and oil used, plus other information, but doesn't require any measurements of the house. For more information on this subject, visit our resource library at HVACRsupplyNOW.com. I hope that you found this information educational as well as helpful, and remember, HVACRsupplyNOW.com is your source for your oil burner nozzle needs.